All right, I want to factor this, and I'm going to use the remainder theorem where states P, the last value, Q, the first value, and I'm going to write out all of these factors for P and then all the factors for Q. So the factors of 16 would be plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8, plus and minus 16. Then all the factors for Q would be plus and minus, I'll get rid of that, plus and minus 1, plus and minus, trying to write too fast, plus and minus 5, and plus and minus 25. So what I'm going to do is write all of these in terms of P over Q. So as you're going to see, like positive 1 over positive 1 would be 1. Negative 1 over negative 1 would still be a positive 1. So I can start to write these out as 1, negative 1, and then go to the next, this 1 over the 5. So 1/5 and negative 1/5. And then the next one, the 25, which would be 1 over 25 and negative 1 over 25. Now I'm going to do the same thing with the 2's. So let's see if I can clean that up a little bit. And so I'm going to have 2 and negative 2. I'm going to have 2 over 5 and negative 2 over 5. I'm going to have 2 over 25 and negative 2 over 25. Okay, so that was the 2's. Now next I'm going to do the same thing with the 4's. So 4, negative 4, 4 over 5, negative 4 over 5, 8 over, oops, I lost my 4's. Still in the 4's. 4 over 25 and negative 4 over 25. Now let's do the 8's. So be 8, negative 8, 8 over 5, negative 8 over 5, 8 over the 25, and negative 8 over the 25. Finally, the 16's. 16 over, 16, negative 16, 16 over 5, negative 16 over 5, 16 over 25, and negative 16 over 25. So all I did was take each one of these numerators and put it over each one of the denominators. Now you're trying to find which one are the zeros. One thing that I might do is put these, definitely in a very quick calculator. So I'm going to open Desmos right here. And so I have f of x equals 25x cubed plus 75x squared minus 96x plus 16. And what's really cool is you can just put in, like, say, f of negative 4. And you're like, wow, she already guessed the 0. Well, I can kind of see it right there, right? But that's what you're doing, is you're plugging each one of these values. So like f of 1 is 20. F of negative 1, I'm plugging in each one of these values. F of 1/5, and I'm looking for all of the zeros. So I can see 1/5 is a 0 if I need to list these. Negative 1/5. But I want to use a whole number, and as you saw, I got f of negative 4. So I am going to use my negative 4 in my synthetic division, which says 2. So this is my 0. I'm going to have negative 4. And then my 25, I'm just copying these numbers up here, 75, negative 96, and 16. So I bring this 25 down, I multiply and get negative 100. That gives me 25. I multiply these, I get a positive 100. That gives me 4, multiply negative 16, and that gives me 0. So writing my first term, remember, is going to be opposite. And then this becomes 25 Now I'm at x squared minus 25x, and then plus 4. I finally can factor the quadratic, and I'm going to try 5x and 5x, and then minus 4 and minus 1. So that would be my, oops, completely factored. But again, if you need to find all of the zeros, that's why something like this would be very, very quick. Say put 2 fifths in. I can see that's not a 0. Positive 2 fifths. And you can just go through here and put every single number in here to be able to find those zeros as well.